Hi everybody, I am Serdar. I am an AWS and DevOps instructor at Clarusway. Today I'm gonna focus on Elastic Load Balancer, in other words, ELB. We don't want any interruption on our website in production environment. ELB manages the traffic on our web servers. In other words, it divides traffic in balance among EC2s. In addition, thanks to ELB, if something happens to one of our instances, the traffic can be divided among the rest of instances and our website can serve seamlessly. What if we don't set up any ELB in our environment? We need to make many settings manually and we have to be aware of any malfunction immediately to direct the traffic to the other servers without delay. We have learned how to install Nginx on our EC2 and how to publish our basic website within Nginx on EC2 instance in previous video. Let's assume that we have two web servers and Nginx is serving on both. The only difference between those EC2s is their website. I've uploaded different websites to show how to manage ELB our traffic. As you see, first server can be seen on website hosted on first EC2, and second server can be seen on website hosted on second EC2. If you are ready, let's get started. You need to log in your AWS account with your credentials and reach the EC2 console page using the Services tab from the top of the page and click EC2. In the EC2 AWS Management Console, select Load Balancers from the left-hand menu. Click Create Load Balancer to start creating ELB. First of all, you need to decide which load balancer you prefer to use. Here we have four options. These are Application Load Balancer, Network Load Balancer, Gateway Load Balancer, and Classic Load Balancer. Our job in this case is set up a HTTP-based website, so we'll continue with the Application Load Balancer. Step 1 is Configure Load Balancer. I'm gonna give a name to my load balancer, first load balancer. And in scheme part, we have two options. If we choose internet facing, this load balancer can handle the traffic coming from the internet, I mean from the outside world, and distribute it to the internal resources. But if you select internal, this time it works only in VPC and is used for our load balancing operations within VPC. In our scenario, we will distribute the traffic from the outside world to two servers inside and reach us from the internet. So let's choose internet facing. For IP address type, choose IPv4 if your clients use IPv4 addresses to communicate with the load balancer. Or choose dual stack if your clients use both IPv4 and IPv6 addresses to communicate with the load balancer. If the load balancer is an internal load balancer, you must choose IPv4. I'm gonna choose IPv4. The listener will roughly listen to which port on which protocol this load balancer is from the outside. Since we will receive traffic from the outside via HTTP, we select HTTP 80 port for now. In Availability Zone section, we can specify the availability zones to enable our load balancer. AWS suggests we specify subnets from at least 2 availability zones to improve the availability of your load balancer. We select default VPC and all the AZ options. You can use optional add-on services, AWS Global Accelerator to create an accelerator and associate the load balancer with the accelerator. You can specify the key and value for each tag to add to your load balancer. Let's choose next, Configure Security Settings. Here we will encounter a warning because we have opened the HTTP protocol and it's not a secure protocol exactly. So AWS suggests opening an HTTPS and using a certificate. However, we do not need to open HTTPS within the scope of this video. Therefore, we do not take this warning into account. Click Next, configure a security group and go on. The security group for your load balancer must allow it to communicate with registered targets on both the listener port and the health check port. The console can create a security group for your load balancer on your behalf with rules that allow this communication. If you prefer, you can create a security group and select it instead. We select the existing security group, click Next, Configure Routing button. Now it's time to arrange inbound traffic. We use target group to distribute the traffic in AWS. Let's determine the rules. For target group, you can create a new target group or use the existing one. We prefer to create a new one. For name, we determine the name of the target group as first target group. For target type, we have three options. These are instance, IP, and Lambda function. If we select the instance option, the EC2 instances we create will be targeted. But if we select IP option, we do it by entering specific IPs. As the last option, we can also set this load balancer to load multiple Lambda functions. We will select instance as we will connect to EC2 instance in our scenario. We select protocol and port that the load balancer uses when routing traffic to targets in this target group. So we select HTTP and port 80. Now let's take a look at the health checks. Health checking is a function used to determine whether the instance is working properly in load balancing. The load balancer checks if the instance is working properly, and if it's healthy, the load balancer sends traffic to the instance. If it's not working properly, it will redirect the traffic to the other healthy instance to prevent interruptions. This is called health checking. Thus, clients connect from the outside will continue to operate without any interruption thanks to the load balancer backed by health checking. The load balancer can fulfill this action over the HTTP, HTTPS, and TCP protocol. All load balancer types are compatible with health checking. In the health checks menu, here we select HTTP again as protocol. For path, it will be the destination path for health checks. Root path is available for us. It means load balancer is going to check the homepage of the website our server is related to. In the advanced health check settings part, we set the rules on how to control the root path mentioned above. For port, the default option is traffic port. This is the port the load balancer uses when performing health checks on targets. Keep it as is. For health threshold, here you decided the number of requests that will be sent to the machine in the background. The default value is 5. It means this machine will query the machine inside 5 times. If it gets positive results from 5, this machine will evaluate as healthy. For unhealthy threshold, we determine how many errors provide load balancer to decide this machine is unhealthy in this part. If load balancer gets 2 consecutive fails from health checks, it will decide that this target is unhealthy. For timeout, we write the maximum number of seconds to wait in case of connection failure. 5 seconds is the default value. For interval, this part shows you how many seconds will pass between each experiment. 30 seconds is the default value and available for us. Finally, success code. It is the code that ensures that the answer is healthy. If it receives 200 of the HTTP protocol, it will evaluate to healthy, otherwise it will say unhealthy. Click Next, Register Targets on and go on. With an application load balancer, the target type of your target group determines how you register targets with the target group. We have two servers listed in the registered targets as you see here. Now we need to make them register, so select both of them by clicking the boxes at left. After that, add them to the registered targets by clicking the Add to Registered tab seen above. They are now under the target group, so we are going to start to use this synchronous with the load balancer. Now let's check all the settings we made by clicking Next Review. If everything is okay for us, then we can click Create tab to create the load balancer. I'm gonna click Close. Here is our load balancer, first load balancer. Now our two servers working with under control of load balancer. The load balancer will analyze the health of these instances and it will distribute the traffic according to this evaluation. It is a provisioning state right now. I'm gonna stop my video and I will start when it is active again. Our load balancer is active right now. Let's check it on the browser that how the requests are routed to different instances with the help of the ELB. To do so, select load balancer named first load balancer. Copy the ELB's DNS name here and paste it your new browser. Your website will be seen here, and when you refresh your page, load balancer distributes the traffic between these two web servers. You can see sometimes it shows first server and sometimes it shows second server. As you can see in this section, we have learned how ELB automatically distributes your incoming traffic across multiple targets, such as EC2 instances in one or more availability zones. Now we know that ELB monitors the health of its registered targets and routes traffic only the healthy targets. Thanks for watching us. See you in the following sessions. Till then, keep in touch with Clarusway community.